In this video we're looking at conversion of area, and I've drawn one of the more complicated shapes that comes up in the short questions. And if you can convert this to a square, which is what they normally ask you, then any of the other things won't be a problem. So the first thing I'm just going to get you to notice is that that shape is actually three different triangles. So just drawn, you can see there the main one and these two other triangles. Now with a triangle, if a triangle has the same base and the same height as any other triangle, then they have the same area. So if we pretend that that's the base of this triangle and then move that down to this line and join it back up to the top here, then we have a second triangle that's the same area as that one, but the advantage is that we're now working along this base line here. We can then do the same on the far side, if you could imagine that that's the base and then this is the perpendicular height out to there. So if I just pull that down to there and join it back up, then you'd have one big triangle that's equal in area to this quadrilateral. So I'm just going to set that up now. So I just took a line parallel to the base, so-called, of this little triangle. So a line parallel here till it cut my overall baseline there. And that essentially moved the apex of that triangle down here. So that triangle there is the exact same area as that one. Okay. So I went over to this side. I already had that line drawn down. I took another one down parallel to it and essentially moved that apex down onto that line. So then this triangle is the same area as that one. I haven't touched the one in the middle yet. There was no need to. So by joining these 2 points to that apex, that red triangle is now the same area as the original quadrilateral. So how does that help me? Well, to convert a triangle to a square, you have to convert it to a rectangle first. Now you might remember even from primary school that if you get the perpendicular height of a triangle and then square it up from the original base, that will result in a rectangle which is equal in area to the triangle, which of course is equal in area to the original quadrilateral. So I've just drawn in that line, which is the bisector of that line. In other words, that is half the perpendicular height of the triangle. And I'm just going to square this up now. So now I'll have a rectangle equal in area to the triangle, which is equal in area then to the quadrilateral. So that's the rectangle drawn in. The last stage now is to convert that rectangle into a square. And you can't jump ahead. You can't go from a triangle to a square. You must follow this procedure, which makes this a difficult enough question, but it's very useful to be able to convert various shapes into a square of equal area, because a square is easier to compare with another square than almost any other shape. For example, that quadrilateral there and another similar quadrilateral over here, it would be hard enough to determine which was the bigger, but if you convert them both to squares, it's very easy to see that. So before I go too far ahead, just going to explain this stage. What I've done here is just simply folded down the edge of the rectangle. So I just put the point of the compass there, opened it up to here and just folded that edge down. Now I've labelled the 2 points that I need, A and B. I think it's useful to do that in the exam. So what I did then was bisected the distance AB. So that's the bisector there, and I found the point C. What I'm going to do now is draw a semicircle, which is the radius CA. So I've just drawn that semicircle in, radius CA, and then from the end of the original rectangle, if I just come straight up until I cut that semicircle. Okay, so I just originally folded down then the end of the rectangle, but just come back to here, which is the end of the rectangle that we had, the blue rectangle. Just come straight up then to the semicircle. That now is the side of the square. So all I'm going to do is square that off using a 45-degree set square there, just come down and up and across. So that final square then will be equal in area to the rectangle, which is equal to the triangle, which is equal to the original shape. So the square then has just been squared off. Once you have that side, of course, a square being a square, the length and the width are the same, or the height and the width are the same. So that square is equal in area to that rectangle, which is equal in area to that triangle, which is equal in area to the original quadrilateral. And that's about as complicated as they get in junior cert.